Now that we have truncated the extra bits and we have got our input, the next step is to generate the Hamming code. So whatever check bits I got in the check bits, if you remember the parity bits, they have a value of p. So I had to remove that p value, and I had to remove those p bits by the parity value. And for that I am writing a code for generating the Hamming code. First of all, I calculate the length, that is the number of bits, because it will not be same as the number of bits in the input binary number. We have extra parity bits here. First of all, I go and find the particular positions where the value is equal to p, and for every p bit, like here I'm writing length of idx. If I have 4 p bits, this loop will run for 4 times. Otherwise, if there are 3 p bits, the code will run for 3 times. So for every p, I'm going to replace it by the parity value. Initially, the parity value, if you see, it has been taken as 0. Now, what is parity? I calculate the number of ones, and whenever I have a number of ones, the parity is incremented by 1. If the total number of ones is equal to even, the parity will be 0. If it is equal to odd, then the parity will be 1. So coming to this part, I start from the particular p bit, and I particularly leave 2 number of bits. I skip 2 number of bits. For example, let us say that my first position, I'm checking for the first position. So I start from the first bit, and after that I go to the third bit, after that I go to the fifth bit. So this idxi value will be 1. So it will start from 1, next go to 3, next go to 5, next go to 7, like that. And I divide the Hamming code into a separate part. The thing may be that the last index, it may be lesser than the number of bits. In that case, I take all the values to the last. Otherwise, I start, for example, for the first bit, I'll be taking values like this. I'll be taking 1 bit, skipping 1 bit, taking 1 bit, skipping 1 bit, like that. In case of second bit, I'll be taking 2 bits, skipping 2 bits, again taking 2 bits, skipping 2 bits. In case of fourth position, I'll be taking 4 bits, skipping 4 positions, again taking 4 bits, again checking 4, skipping 4 conditions, and so on. So basically that skipping part is being done here. I'm taking an individual number of bit, like 1 bit or 2 bit, and storing it in check part. After calculating the check part, I find out how many number of ones are there. The total num L, this will calculate the number of elements. So I find out how many number of ones are there and add it into parity. Finally, what I do is, after all the check parts have been calculated and the parity of all the check parts have been calculated, I end the loop, and in Hamming code, in that particular position, I replace the p bit with this value, the ASCII value 0 added with parity divided by 2, the remainder. Mod is equal to the remainder. Like in C, we have a modulus operator to calculate the remainder. In MATLAB, we do it by using this mod function. So if the parity will be odd, I'll get 1 plus 0. So 1 value will be loaded. Otherwise, if the parity is even, I'll get a value 0, and 0 plus 0 will give me 0. So Hamming code will be done like this. Now let me show you the output of this thing. So now what I have got is, I have got the binary number, the check bits, and Hamming code. Let me show you all these 3 values separately. The binary number was this thing, the check bit was this thing, and I have calculated the Hamming code. The document which you have sent me, you can verify with those examples. You'll get the same Hamming code, or you can calculate your own Hamming code manually.